Now that you have all the tools that you need, let's talk about how to solve square root equations. And this is a culmination of a lot of different skills that we've discussed before. But in terms of square root equations in particular, the idea is that you want to get the square root by itself on one side of the equal sign first, and then square both sides in order to get rid of the square root. So for example, if you have x equals 5 plus the square root of 3x minus 11, we want to get the square root by itself. So we subtract 5 on both sides of the equation first. So on the left side, we have x minus 5, and on the right side, we have the square root of 3x minus 11. And we square both sides of the equation so that we can get rid of the square root, because square and square root are opposite operations. So we square both sides of the equal sign, square and square root because they're opposite operations, they cancel each other out. So on the right side, we just have 3x minus 11. On the left side, note that you're not just squaring the x and you're not just squaring the negative 5, you're squaring x minus 5. So you have to basically multiply this out as if you're multiplying binomials. So x minus 5 times x minus 5. So if we do that on the side here, x minus 5 times x minus 5, we would have to FOIL. So if you multiply the first together, x times x gives you x squared. Then the outsides, x times negative 5 gives you negative 5x. Then the insides, negative 5 times x gives you another negative 5x. And then the last, negative 5 times negative 5 gives you a positive 25. After you do a lot of these squaring of the same binomials, you'll notice that basically what happens is you have the first one squared, that x squared, the second one squared, so negative 5 times negative 5, which gives us 25. And then the middle one is going to be negative 5 times 2, so negative 10x. So we have x squared minus 10x plus 25 equals 3x minus 11. And because we talked about the zero product property, so what you want to do is you want to get 0 on one side of the equation and then factor. Okay, so we subtract 3x on both sides of the equation, and we also add 11 on both sides of the equation, so we might as well do them at the same time. So on the left side, we have x squared, negative 10x minus 3x gives us negative 13x, and then positive 25 plus 11 gives us a positive 36, and on the right side, we just have 0. And again, we have a trinomial where the leading coefficient is 1. So we want two numbers that multiply to 36 and add to negative 13. And so the two numbers that multiply to 36 and add to negative 13 are negative 9 and negative 4. So we can factor this as x minus 9 times x minus 4 equals 0. And by using the zero product property, we know that means that either x minus 9 is going to equal 0 or x minus 4 is going to equal 0. If it's the first one, if we add 9 on both sides, that gives us x equals 9. And if it's the second one, we add 4 on both sides, and that gives us x equals 4. And again, how do you tell what your answer is going to be? Is you have to plug it back into the original equation to see what works. So let's try x equals 9. So if you plug in 9 for every time you see x, so we have 9 equals 5 plus the square root of 3 times 9 minus 11. And let's see if the left side equals the right side. So 5 plus 3 times 9 is 27, minus 11 gives us 16. So we have the square root of 16. Square root of 16, because it's a perfect square, we know that this is 4. So 5 plus 4 on the right side, which gives us 9. So 9 on the left equals 9 on the right side, so that works. Let's also substitute 4 in for x. So if you substitute 4 into the original equation, you have equals 5 plus 3 times, plus the square root of 3 times 4 minus 11. Okay, so we have 5 plus 3 times 4 gives us 12, minus 11 gives us 1. So we have the square root of 1. Square root of 1 is really just 1, so 5 plus 1. Now 5 plus 1 actually equals 6. So 4 and 6 are not equal to each other, so this one does not work. So what we call this is an extraneous solution, where we got 4 as a solution to a problem, but it doesn't work in the original problem. So 4 is not going to be part of our final answer. It's only going to be x equals 9.